Good afternoon, students. In our last session, we discussed hypothesis testing, and steps were, in brief, null hypothesis or alternative hypothesis are specified. Then step 2 was a level of significance is selected by the researcher. So this could be either 0.05 level or 0.01 level. Based on the parameters specified in the null hypothesis, the statistics is calculated, and the last thing was decision is made whether to accept or reject the null hypothesis. And as I told you, in this regard, the p-value or probability level is computed. Now, in this session, one-tailed and two-tailed tests. One-tailed and two-tailed tests. Any hypothesis can also be one-tailed or two-tailed. Up, what does it mean by one-tailed or two-tailed? We need to understand hypothesis whether it is for a one-tailed or two-tailed test, so that we can find the critical values in standard tables. Standard, normal, Z distribution table and T distribution table. So how can we say if it is a one-tailed or it is a two-tailed test? A one-tailed test is a test looks for an increase or decrease in the parameter. A one-tailed test looks for an increase or decrease in the parameter, while a two-tailed test looks for a change, increased or decreased in the parameter. So a one-tailed test checks only one of the tails, upper or lower tail, of normal distribution curve. It is used in a collection of data to carry out a test of significance when the investigator is sure that the results will go in one direction. While a two-tailed test checks both upper and lower tails of the normal distribution curve. So, in a statistical significance test, a two-tailed statistical test is used when there is a possibility that results may occur in either predicted direction. So, it is used for statistical significance in null hypothesis testing. It is termed as one-tailed when certain direction is given to the hypothesis, or when hypothesis is directional. So remember, it is termed as one-tailed when certain direction is given to the hypothesis or the hypothesis is directional. For example, if the researcher study if gender difference exists with regard to emotional intelligence, that females show higher level of emotional intelligence or males show higher level of lower level. So is there any kind of difference? So if a researcher wants to study if gender difference exists with regard to emotional intelligence, a one-tailed hypothesis would be females have higher emotional intelligence than males, or males have higher emotional intelligence than females. So in one-tailed test, in order to reject a null hypothesis, the score needs to fall in the upper tail. That is in the top 5% of the distribution. A one-tailed test can be tested in either direction, either of the direction. And in case of two-tailed hypothesis, the hypothesis is non-directional and will be stated as gender difference will exist with regard to emotional intelligence. In case of two-tailed test, a null hypothesis can be rejected when the score falls in the either of the top 2.5% of the distribution. Thus, the level of significance is maintained at 0.05 level. As the level of significance is taken as 0.05 level, it can be taken at 0.01 level as well, in which in which case the prediction will be based on the lower tail. Errors in hypothesis testing. Let's talk about errors in hypothesis testing, which are generally made by the researchers. As we already know that hypotheses are simply assumptions that may be proved to either correct or maybe it is incorrect. So it is possible to arrive at an incorrect conclusion about a hypothesis for many reasons, like sampling procedure which was adopted by the researcher is faulty. Sampling procedure adopted by the researcher is faulty, or data collection method was inaccurate, or study design selected was faulty, inappropriate statistical methods, or the last is conclusions or interpretations drawn were incorrect. So the common errors that might occur when testing a hypothesis are type 1 error and type 2 error. Null hypothesis is rejected. So type 1 error. Null hypothesis is true. Type 1 error. Null hypothesis is false. Decision is correct. Null hypothesis is accepted. Decision is correct. Null hypothesis is true. Null hypothesis is false. Type second error. Type 2 error. So, a researcher will be making a correct decision when a false null hypothesis is rejected. Remember, a researcher will be making a correct decision when a false null hypothesis is rejected and when a null hypothesis that is true is accepted. However, it may happen that a null hypothesis is rejected even when it is true, and this is termed as type 1 error. When null hypothesis is rejected even when it is true. So this is termed as type 1 error. On the other hand, when a false null hypothesis is accepted, then it is termed as type 2 error. So remember, type 1 error, rejection of a null hypothesis when it is true. Type 1 error, rejection of a null hypothesis when it is true. Type 2 error, acceptance of a null hypothesis when it is false. Acceptance of a null hypothesis when it is false. So type 1 error is denoted by alpha and type 2 error is denoted by beta. So let's take an example from popular moral story about Panchtantra, which you all are familiar with. For example, Lion and Boy. Let's say that null hypothesis is that there is no lion present in village. Type 1 error will be roar of lion when there is no lion present. So that is the actual condition was there was no lion present, though the boy wrongly indicated there was a lion present in the village by shouting. So this is type 1 error. Likewise, null hypothesis is assuming that lion is not present. Type 2 error would be to do nothing, not roaring lion, when lion is actually present. But is the real condition is that the lion was present. So, however, the boy wrongly thought no lion was present and proceeded to play with his classmates. This is an example of type 2 error. Random and constant errors. There are also a kind of measurement or observational error which takes place either due to some defect or by chance. An error in measurement is called as random error. An error in measurement is called as random error. When the observational values are consistent in repeated measurements of a constant attribute or quantity. So it occurs due to the chance factor. Systematic or constant errors are the errors that occur due to an inaccuracy involving either the observation or measurement process. That may be due to defective apparatus or inaccurate observation. They are not a result of chance factor. So let's go through our important key points of this topic. The formulation of In formulating of a hypothesis, it is important to ensure that it is simple, specific, and conceptually clear. It is able to be verified. It is rooted in an existing body of knowledge and is capable to be operationally used. There are two broad type of hypothesis, null hypothesis and alternate hypothesis, which we discussed in this session. So important concepts involved in the process of hypothesis testing: one-tailed, two-tailed, type 1 error and type 2 error of a test were also discussed in this unit. What was type 1 error? Rejection of a null hypothesis when it is true. Type 2 error: acceptance of a null hypothesis when it is false. Null hypothesis: the hypothesis that is of no scientific interest, sometimes the hypothesis of no difference. Alternative hypothesis: statistical term for research hypothesis that specifies values that researcher believes to hold true. One-tailed test: a one-tailed test looks for an increase or decrease in the parameter. Two-tailed test: a two-tailed test looks for a change, increase or decrease in the parameter. In our next session, we will discuss significance of hypothesis and major characteristics of hypothesis, its importance.